Welcome to the presentation now of the next generation of marine fuel cell systems from Corvus. So I'm presenting today as product architecture responsible here from Corvus. That means we have currently a team of about 8 people working on the actual design and process for these systems, but we have now a total team of 20. But I will tell you more about this. Slightly on my background, I haven't been in Corvus for very long. I've been here for slightly above 6 months. Previously, I was working 24 years with Bergen Engines, with engine design for gas engines and diesel engines, process simulations, and also management of the engineering team the last 5 years there. Before that, I was 2 years with DNV classification. And my background is as a master's education from NTNH, or from old NTH in Trondheim. So I will dig into it and get started. I thought I should tell you a little bit about Corvus. Might not be very well known to everyone, so it's worth the presentation. It's a reasonably young company. It was founded in 2009 in Vancouver, in Canada, by some dedicated souls that saw a big potential for batteries and various applications. The journey was, starting with batteries for, what do you call that? Loading cars for, for luggage and so on in airports. And it was also moving towards traffic lights in Vancouver City. Lots of strange applications. But soon after, it was clear that the marine market of batteries in Norway was becoming very expanding. And from that, it led on to big focus on marine applications, where really the biggest focus is today. So the headquarters has been moved from Vancouver to Norway. So currently here at Midtun in Bergen. We have multiple production sites. We have a production site here in Bergen, which is a completely robotic factory with 4 people operating it. We also have production sites in Vancouver, of course. We have also a team sitting in Porsgrunn, in Greenland, southern of Norway as well. And we are now planning to expand the production also to move to the US, to Seattle. And there's also discussions of moving production towards Asia as well. So it's a lot of expansion going on in Corvus at the moment. So to support all this, there is a global sales and service network. Currently, there are more than 180 people employed across this big organization I just described, but it's increasing rapidly. Regarding the team, so I've written here superior battery knowledge. We are now expanding to become superior fuel cell knowledge as well. So that's really the focus of what I will tell you more about later today, but thought it was worth also to share some of the background for the existing organization in Corvus. Culture for innovation is definitely the backbone, and a strong maritime DNA, which has been, conserved to become really, the essence of Corvus as it is today. So we only work with maritime organization, or anything that's, related to salt water. So there could be land applications for charging stations, for ferries and so on. But anyway, it's related to maritime use. So the entrepreneurial skills are definitely important here. And as you will see, we are also focusing quite a lot on R&D in order to keep the advances we have on battery, but also to excel and try to get into the fuel cell business as quick as we can too. So regarding ownership, currently it's privately held ownership today, with some really strong owners, as you see below there. So you have Shell and Equinor and Hydro and BW Group, which is really Bergesen Group from Singapore, as the main owners. And then there is a Canadian flag that signifies, the original owners and startup people from Vancouver. So they've been staying along as very, confident and long-term owners. And what's happening now is that Corvus is going on the stock exchange, actually, probably this month, at least this quarter. So it's happening quite rapidly, and it's all because of need of capital in order to do the expansion plans a reality. So I will move to the next one. And this is really the focus of today, because I will tell you more about the fuel cell development that's taking place. And it's really, hedged for through what's called hydrogen NOR or H2 NOR, which is then a consortium of some rather big partners. So one that I should, really emphasize here is Toyota, because the fuel cell technology that we are building on is based on the Toyota Mirai development from Toyota. So a lot of the components that's being used for Toyota, but slightly modified and engineered into, what should I say, an industrial unit, is the basis of the work that's taking place here in Corvus. But with us on the team to ensure that we have a good application for the maritime use, we have lots of good partners. We have Equinor on the user side and also for the offshore side, particularly, of course. We have Norled and Wilhelmsen as the users. Norled as a ferry company, Wilhelmsen more as a cargo operating company, amongst many things. We have Maritime Clean Tech, which is the organization taking hand of, what should I say, the organization and the communication within the consortium. We have USN, the University of Southern Norway, which is experts on, what should I say, explosion and explosion risk studies and so on, which is quite essential when you handle hydrogen. And we have LMG Marine, which is famous for ship design. So we have no less than 3 full designated ship designers also to be a part of this work that we do to ensure that we get a good ship solution. In addition to that, we have some also some collaborative partners in addition to this. So I think all in all, you could say that we are probably a team around 50 people now working on this. The consortium is funded by Innovation Norge and Forskningsrådet, and we call that the H2 NOR organization. So what you see on the right-hand side of this slide is the robotic factory that we have downstairs from Mitten here, where I work today, which is really consisting of a fully roboticized factory making several units for battery modules for ships per day. So regarding the timeline of what we are doing, so our idea is to say that we have started the study of developing the marine version of the fuel cell system from Corvus this year. We started that in the beginning of 2021, and we are doing a concept design to get it ready for concept reviews and so on early 2022. And we will then target an approval in principle by class, working together with DNV on that. And we will then move on to the detailed design and test phase that will be concluded by the end of 2023. In there, we will include some sailing pilots, and we will then, as a part of that development, target to get a full type approval for the fuel cell systems from Corvus. And to build on that, we will then move into mass production from there and onwards. So to accompany this slide, I think it's worth just sharing this one to say that it's exactly the same timeline, but not being a part of the H2 NOR, but now rather looking into what is the Corvus long-term view, and that is to say that we plan to move forward with second or more type-approved versions based on further developments coming in the future, also solid oxides and further developments of the PEM cells, which I will tell you more about. So I will quickly progress into looking into the major project goals. So today, the main project goals are to develop, demonstrate, and certify a mass-producible, modularized maritime PEM-based fuel cell system in a power range from 320 kilowatts all the way up to 10 megawatts. And our ambitious target is to do that actually within 2359 at the 31st of December 2023. And I think the big advantage that we have working from Corvus is that we already have the battery technology well within our sleeves already. So we are planning to also have this as a, what should I say, integrated system with both fuel cells and batteries in what we call a fuel cell and battery information system. That should, make sure that we actually get full utilization of all the benefits from the batteries and for the fuel cells in a vessel application. So that's a part of the project and an important one. I have a slide here that might be appearing to be a little bit crowded, but I'll break it down. So if we look at what's on the top of this dotted line, this is the current battery business that we do in Corvus. And basically, Corvus, we don't make the battery cells. We buy them as a raw material. And they could be bought from any of the suppliers worldwide that actually satisfy the criteria of the batteries. But what we do then is that we build them into modules and into battery systems. And that means that we actually take care of a full battery system design, both in terms of packaging, but control. And of course, I think the biggest part of that will be actually the type approvals. Because the type approvals will make sure that these installations are safe and that thermal runaways will be avoided and that you can handle that in a system that's safe for a ship. So then we actually take this offering and we bring that towards the system integrators. And we work with any system integrators. We don't have any particular ones that we tie ourselves with. We would like to sell to them all. And then the system goes to the end user and in operation. So for the future, our plan is to do what we show below the dotted line, which is really to say we would like to tie with us a fuel cell manufacturer. And we would like to use this, preferably a whole system like we show here, both including the fuel cell stack, the auxiliaries, and the fuel cell control system as a module, as we have done today. We would like to do then exactly the same for fuel cells as we have done for batteries. We would like then to do a full system design with this fuel cell basis, do a control and packaging system for that, make sure it's safe, add to it the marine type approvals that's going to be needed, working both with the class and the flag, and then to offer this together with the batteries to the system integrators and then bringing it into operation with the end users. So our development is now really, strong in the sense that we already have the technology of knowing how to do the type approvals for batteries. And we will use a similar, way of approach to make sure that we get the same type of approval for the fuel cells. A little bit about Corvus Energy. Why us? So we would say that, okay, we have a solidity in knowledge in the marine product development already. And it could be added here as a fun fact that Toyota was the one who actually was seeking a partner for bringing their fuel cell products into maritime use. And they were looking across the market of who they actually would like to cooperate with. And they came to Corvus, and Corvus said, okay, that's an interesting prospect. And then there was a lot of studies taking place afterhand in order to see whether that actually was the right partner. But as it has developed now, it has become a viable partnership and it's moving steadily onwards. Also, regarding design and operation, so we believe that the fuel cell and battery information system software will simplify and optimize the use of both fuel cells and batteries for the end customers and also for the system integrators. So we would like to be more or less a one-stop shop to actually get a full plant of this sort of technology on board a ship. And also that means we have strong partners with high production volume. So I think it's fair to say that I think Toyota today is the world's biggest manufacturer of fuel cells. And that should also, contribute to make us a cost competitive supplier of marine products with fuel cells as well. So building on that, we have the existing markets for batteries, which are all kinds of applications you could really envisage. So that in all really makes it a strong proposition for making it successful as well for the future. So just a little point regarding what that means. So if you have short distance routes or long distance shipping, it really means that the packaging, or what should I say, the sizing between the batteries and the fuel cells, I realize this is probably not the best symbol, but that's the one I came up with here. So the sizing between the battery and the fuel cell plant will vary depending on how far you want to go. But clearly, the further you want to go, the more size you have to build into your fuel cell system. With short routes, you can actually do with a small support for fuel cells, and you will be able to, satisfy your application. But basically, what we are looking at is that, at least at the moment, the analysis on the applications we've done so far show that a sort of a 50-50 split between batteries and fuel cells could be a good place to be. So in terms of the cost of ownership, clearly there will be several things to take into consideration, both regarding the cost of fuel, which is definitely there, but there's also going to be the cost of the electricity if you want to actually do the charging by key, for instance. But also it's going to be the first cost of the system to actually do the purchase and to get the system on board your ship as well. And then, of course, it's going to be a matter of cost of operation over time in terms of degradation, wear and tear, and what sort of service strategy the systems will need, and so on. But basically, we are in a tough market, so it means that we have to prepare ourselves to compare to the best. So, just to be aligning ourselves towards the previous example I showed regarding the dotted line. So here we say that the current business is typically, for the battery installation system here to the left, and the combined battery and fuel cell system to the right. So the current offering is that we have the battery management system controlling the battery and feeding that towards the interface of the ship to the power management system of the ship, and feeding into the grid of the ship to combine this with, for instance, if you have a genset on board, or then you have the consumers with the, for instance, like we show here, the main propulsion engines or the thrusters or whatever consumption you need on board. But then the battery will then, be on the Corvus supply side and feed into the system integrator through the DC or AC/DC and then feed into the grid of the ship. Likewise, for the future, we will then combine both the battery system together with the fuel system with the DC/DC converter to make the same level between the two, and then feed those via an AC/DC converter and then into a transformer and then into the grid of the ship. So in that way, we believe that we can do a simplified integration toward the ship owner, and we could have also a real-time degradation information portal to make sure that we actually feed the customer with sensible and good data by the time they need it in order to do planning of maintenance and so on. So basically, a short and sweet presentation now, what's taking place in Corvus regarding the fuel cell development so far. But my questions to you is, do you have any questions for me?